you who don't know, that didn't attend the session last week, etc. My name's Lawrence Dawkins-Hall. I'm an applicant support mentor for the Science Council, and I'm going to be giving a session as part of the Winterfest for MI Talent on behalf of the Science Council. And today's session specifically is really synonymous with the competency form. In other words, top tips for completion of that form. And as it says there in the small print, at the end of the session, the idea is that you can complete the competency form with confidence and autonomy. Let me just make a common refrain that I make every time I speak, which is, although you will put your in the final analysis, you will put your session.
Oh, could people just mute their mics, please?
Really scruffy as you do it. So, like, mine is a bit scruffy. So I'm just like.
Thank you. Yeah, if you could keep your mics muted, especially as the session's being recorded. So the idea is that you complete this form with confidence and autonomously, but let me just say that in the build-up to compiling your competency scenarios, I am prepared to work with you. So the autonomous bit really is about completion, the actual sort of commencement or submission of the application via the online application portal, CAP, Common Application Portal, which we talked about last time, and there is a video pertaining to the Common Application Portal, benefits of registration, etc., etc. So today's session is really, as I say, synonymous with completion of that form, which is actually the large part of your online application. Just to sort of put in context, competency examples are in the context of 3 registers that will be spoken about today: RSci Tech, Registered Science Technician, RSci, Registered Scientist, and CSci, or Chartered Scientist. And actually delineation of those registers was a function of the session last week. So I am hoping that most of you here will have a clear idea of which register, based on your own skills and experience, you're likely to pitch for. The only other thing I'd say, for the sake of completion, is there is another register which the Science Council promulgates, and that's CSci Teach, and that is designed primarily for secondary science school teachers, so it won't be the subject of today's workshop. Before I move on, let me just say that I've mentioned the fact that you can contact me in relation to this and the previous sessions, questions you have and you would like clarifying in order to complete your competency form before you hit that submit button in terms of your own CAP application. And I've given you my Science Council email address here. So I haven't actually broken down the agenda, and that's primarily because essentially this workshop today is synonymous with completing the competency form, and that is basically work case scenarios that I will give you to illustrate completion of the form, and you will recapitulate those in your own form. There's also a way of writing your work case scenarios in your competency form, in your CAP application, which is conducive to actually passing muster. And I'll break down how you put together what I refer to as a competency answer. So interactivity is expected. So feel free to put something in the chat or to come off mic if there is a burning question. But let me just say that the session is really in 2 halves. The first half is more didactic. You will be on your mute a lot more because I'm just going to be presenting examples of the competency sort of work scenarios that you can reflect upon and recapitulate in your own forms. And as I mentioned, how do you go about constructing a competency answer in terms of effective prose? After something like a 10-minute break, we will sort of work more collectively. And by that, I mean there'll be a group discussion in the main sort of room. And there's also a couple of breakout rooms as well. And we'll do this systematically for each of the competencies, A, B, C, and D. There's competency E, but that is one that we'll go less into, and it'll become clear why in a minute. I just want to remind you about the fact that there are resources both on the Science Council website and indeed on the license body associated websites. License body membership is a prerequisite of CAP application. And once again, that is something that was broken down in Monday's session. So if you weren't at that session, there was actually a recording which Sarah can distribute to you. But I want to show you this particular slide because this is basically a Google Padlet. And what I've tried to do in this Padlet is consolidate a lot of the information from the Science Council website and also bite-sized videos pertaining to particular aspects of professional registration, such as how do I go about completing my competency form? Why apply for professional registration? What are the benefits thereof? Okay, and this is all brought together in this one document. So what I just want to do now is a snapshot of which registers you think you are. So if you go into slido.com and put in that code, or indeed if you have a phone and you take a picture of that QR code, you should be able to actually vote and actually declare which register you are. And what I'm particularly interested in is not your own respective registers, it's the number of people that declare themselves as still not being sure. And it may be that it's because you weren't here at last Monday's session. How am I doing, Sarah?
Yeah, fine. So you've got, can you see the responses on that, Lauren?
I can, I've got 13.
Yeah, so we've got 20 people on the call. So there's probably a few people, but actually the code seems to have worked for some people, but not others. So I would go with what we've got because the code, I tried it as well and I couldn't get the code to work, but it seems to have worked for some people.
Okay, all right. Apologies for that. What I'm particularly interested in is the not sure. It's higher than before, and I think people that attended the first session were confident of their register. So I have to infer that these are people that have come for the first time and omitted the first session. So what I want to do now is just draw your attention to the fact that there is actually a video that's included with this presentation. This is part of the Science Council YouTube offering. 1 second. So the first thing I should talk about. So basically, this is part and parcel of this presentation, and there are a series of videos, as I've said, but let me just say I was hoping to actually get the home screen up. What the home screen says is that basically an RSI tech is someone with a year's experience, so they can carry out a standard operating procedure independently. They can generate that data independently, but they may not be able to improvise or troubleshoot on a technique. RSI, in brief, is someone who has 2 to 5 years experience, can do the aforementioned, but also has the ability to actually troubleshoot based on that additional experience. And as part and parcel of the competency application as an RSI, it's a good idea to actually include any training of people that you do as part and parcel of your role, whereas that's not really expected in terms of competency answers for an RSI tech. A CSI is quasi-managerial. You don't have to be a team leader. You can actually bench supervise somebody as opposed to just train them. You have an input in their data. It may be that you're involved in a series of projects. And it could be that you're actually setting up methods from scratch and also dealing with people away from the lab, such as estates and services, etc. So it's about communicating competency C, which we'll come back to, with different constituencies. But take a look at the recording for those of you who don't know from the first session, and look at these additional materials as well. So we're going to sort of dive straight in, I think, into the essentially what this session is. What is the remit, which is essentially to talk about how to actually compile your own competencies. And competence really is the vernacular that the Science Council uses to describe your knowledge, skills and behaviour pertaining to your job. It isn't simply technical talk. It isn't what you do at the bench or at a computer or in the field. There is, however, a competency, application of knowledge and understanding, where you'll have the ability to talk about that. But it's also about how you plan and organise your time, personal responsibility, the different types of people that you talk to, be that engineers, be that people that train who are specialists within your own field, interpersonal skills. Professional practice is about standards within a lab, and I'll elaborate at that on a second. And professionalism is really divided into two subcompetencies, E1 and E2, and I'll come back to the subcompetencies in a second or two. E1 is really synonymous with things like EDI, data protection, the sorts of things that we're all expected to do, and indeed many of us are expected to actually take online mandatory courses pertaining to that. And E2 is really synonymous with CPD. So what I'm going to talk about, the competency answers that you can use, your own workplace scenarios which you use to populate your own competency form, filling out the competencies and subcompetencies thereof, can be taken from the last 3 to 5 years, okay? And moreover, they can actually be taken from 2 jobs. So if you feel you have one job in the last 3 to 5 years that's more conducive to, say, communication, which would say be competency C, and you have another job that's much more technical, which is more conducive to technical talk, shop talk, which is competency, primarily competency A, but to some extent competency D, as I'll make clear, then you can actually mix and match scenarios, as it says there, from 2 jobs. The sort of workplace environment that you derive those competencies from doesn't necessarily have to be a paid job. It can be an internship, it can be freelance, it can be volunteering work, as long as it's in a professional environment. And a PhD, for example, which is essentially a job plus additional study, is perfectly valid in terms of 3 to 4 years experience. And for each of the subcompetencies, which the competencies that I've just outlined and I'll elaborate on in a second are broken down into, you have about 1,000 words. There's a 1,000-word limit with the online application portal, or CAP, for each of those subcompetencies. And just to do a quick little bit of arithmetic, for competencies A, B and C, there are 3 subcompetencies thereof. D is 4, B can be 4 for CSI, and E, as I've said, is E1, professional quality, diversity, etc., and CPD. So that's a maximum of 16,000 words if you use up to 1,000 words for those 16 subcompetencies that I've just defined in a cursory way. What I'd like to do now as an introduction to how to think about your own competency portfolio of work is I'm just going to play you a 5-minute video by the Science Council. And then before the break, we're going to build on salient points that have been mentioned in this video. So I'll start this now.
You're applying to our national community of professional scientists. As part of your application, you'll be completing a competence report. This is the main part of your application, and the bit where you get to tell us all about your role in making science happen. The competence report has 5 sections. It is important to assessors that you provide key details. This short guide will help you write a competence report that maximizes your chances of being accepted onto the Science Council first time round. Before we look at the competence report, let's think of some moments in your career that you are especially proud of, and write them down. Times when your actions brought a project together, when you turned a problem into a solution, or when you completed a task to a very high standard. Nobody but you will see these notes, so write down whatever you want. Next, let's take each example and think about what skill it highlights. There are no right or wrong answers. You're just untangling your experience into separate skill sets. For example, let's say you improved the way a sample is collected. Which skills did you use? If you had to interact at length with a colleague, then that's an example of interpersonal skills at work. If you had to read up on a theory or technique and then put it into practice, then you're applying your knowledge. If you sourced some new equipment or a new method that would save time or money, then those are process improvement skills, which contribute to your professional practice. We want to understand not just what you know, but how your understanding informs your problem solving. It can be helpful to look at verbs as clues. For instance, if we ask you to tell us how you assess and select appropriate scientific techniques, procedures, and methods, the keywords are assess and select. Don't just tell us what technique or procedure you used. Tell us how you decided it was right for the task so we can see your reasoning. The prompts will be slightly different for each register. But if you are asked how you analyze, interpret, or evaluate something, use these as hints when drafting your response. When do you take personal responsibility in the workplace, either for yourself or for others? Maybe you write risk assessments for your laboratory, or perhaps you once saw a recurring issue in a standard practice and shared a better alternative with your colleagues. We want to see that our scientists can demonstrate superior people skills. In this section, you will demonstrate communication between colleagues, peers, and decision makers. This section is about procedures, methods, and resources. Think about times when you have chosen various methods and techniques, and any steps you've taken to improve resources in your workplace. We want to see that you understand your relevant codes of conduct and practice, and can explain why they are necessary and how you adhere to them. Show us how you maintain and enhance your own professional development. How do your examples fit into each of these areas? Some might fit into more than one. If you need to, go back and explore each section again. Once you see which examples demonstrate each competence, you can start writing your report. Let's look at what a good report looks like. Your opening few lines outline the problem or situation, or give an overview of the task you're going to describe. Now, tell us what solutions you proposed, or how you made your task work. As well as what you did, tell us why you did it, and relate it back to the subject heading, like knowledge or interpersonal skills. Use I as much as possible to tell us about your personal contribution. Next, write about how you implemented the solution, or how you overcame the problem. To make your answer especially strong, round off by relating this back to your day-to-day job, and how it enabled you and your colleagues to do a better job in the long run. Your example may be more or less complex, depending on which register you are applying for, but the principle is always the same. This matrix will help give you an idea of the level your competence report should be at. You can either pause here or find the links at the end of the video. A very common mistake to make is to just include your inputs. Outputs are even more important. They show whether your skills are making a difference. Here are some simple examples. Make sure you include outputs in every section. Finally, it's a good idea to ask your mentor or sponsor to check your application before you send it. We have lots of resources to help you complete a brilliant competence report. If you need more help, just email us. Remember, the competence report is just about proving the things you already know. Good luck!
Okay.
Lawrence, I've just had a question. I don't know whether you want to answer it now or
Yeah,
at the end.
no, I'll answer it now.
Somebody's asked, with the volunteering option, how closely related to the work does volunteering have to be? So, for example, this person has spent 2.5 years as chair of in a large town council.
Yeah, that's a tricky one for me. I would say in the main, it is about transferable skills, but I think if that person would like to email me and I'll seek further advice on that. But as I understand it, even though it's transferable skills, I think they'd prefer it if it was in a scientific environment, something in some way in a scientific context related to your day job. But don't quote me on that. And if that person wants to drop me a line, I will seek further guidance on that. But I think it is about science, voluntary and your day job.
Okay, thank you. That's very helpful.
All right. So I'm actually now going to go on to this. And what I'm going to do is I'm going to give you pictorial examples of those 5 competencies so that you can reflect upon these yourself. And I'll make some comments in relation to how that might be applied to the 3 aforementioned registers. But let me just make a couple of points now. The first is outputs. So whatever work case scenarios you use, be that volunteering, say, for field work as a biologist, or if you're in a paid job as a biologist or a chemist, make sure you choose examples where what you have actually identified as the problem or situation, to use words in the videos, is actually, you can demonstrate that it's resolved. Okay, so don't choose a situation or problem that might actually match the competency objectives, but not then provide outputs, some way of demonstrating that the solution that you've implemented has actually solved the problem. I've actually had, as an assessor, to digress, I give these workshops for various organisations on behalf of the Science Council, including MI Talent, but I also assess competency applications. And I can think of one application where the person selected a plethora example that, in terms of identifying a relevant situational problem, matched the competency. They then, in their second paragraph, talked about what they did to actually solve that problem, but it wasn't clear to me from a third paragraph whether the problem or situation had been resolved. So a corollary of what I just said is I would break down your answers, and we'll talk more about this, into 3 paragraphs as I've outlined. And because effectively they'd only given me 2, I had to actually fail that competency. So be judicious in how you choose your examples from the last 3 to 5 years. Okay. Let me also make it clear, and there's some cartoons relating to this, that you can use the same examples recontextualized for the 5 headings here, and how you mix and match those competency statements, how you actually permute or put together your own competency form up to those 16,000 words, 1,000 words in 3 paragraphs, is entirely up to you. You can take different examples for each of the competencies, the 5 competencies, and actually recontextualize those in the context of the 3 or 4 sub-competencies thereof. Or you can take a theme and use it for different competency examples. And I'll give you a cartoon illustration of how to mix and match. Okay, but there are, as it said in the video, no right and wrong answers. All right, this is not objective. It's not objective in the way that, say, physics or maths is, as long as your prose, your scenario, can be made to match the objectives of the competency statements. And these are provided on the Science Council website as part of their support material, and incidentally also incorporated into the actual into the actual fields associated with the CAP application, then that is fine. That is fine. Okay. So let's talk a little bit about the 5 competencies. What we're not going to do today is talk about the sub-competencies thereof, but let me make 2 points. There's a slide in a minute which shows you a breakdown between the 3 registers of one of the A competencies. It looks very busy, even by my standards, but it's just there as reference to let you appreciate that there are different sub-competencies. But what I've done at the end of this talk, and it's purely reference, okay, is I've actually included for all of the sub-competencies, A1, A2, A3, B1, B2, B3, etc. I've given examples for each of the registers that would match that particular sub-competency. So it's quite a number of slides that are tagged onto the end of this presentation, and that's another reason for actually wanting to get this presentation itself rather than just listen today, because ultimately it is about passing it into your sub-competencies. So those slides at the very end, which are the most granular I have, will be extremely useful. So application of knowledge and understanding. This can be about literally optimizing a technique, okay? Now, what I've shown here for life sciences is something called PCR, okay? But it can literally be anything in a lab or in an office, okay? It's what you use in order to carry out, say, wet bench science or crunch data, whatever it is you do. And what I'd say is, think of your job holistically. So by that, what I mean is, if you are a bench scientist, if you are a chemist or a biologist, for example, you're not just pipetting things in tubes. Quite often today, you're feeding those into machines, and it's the machines that actually generate the actual data at the end. And the machines need upkeep, okay? Maybe you can improve on a program in terms of how the data is analyzed by those machines. So think about that in addition to your pure data analysis or bench science. So as an R-Sci and a C-Sci, you would talk about how you actually resolve problems with a particular empirical technique like PCR, or how you resolve problems with a machine, okay, that generates your data. For an R-Sci tech, you just need to demonstrate in terms of your A answers the understanding behind what it is you do. You don't necessarily have to actually pick an example of where you're resolving a problem or a situation, because that in many ways is above the pay grade of an R-Sci tech. It's about demonstrating that you understand the science behind data generation with your instruments, or wet bench science with pipettes and tubes. It isn't just about being in a lab. Professional registration applies for anyone in STEM. E in STEM is engineering. Many engineers work outside, so it's about adapting perhaps methods in a lab to working in the field, okay? The other thing I should say is Competency A, the bootstrap statements for Competency A are not exclusively about technical science. It's the application of knowledge and understanding. So, for example, working up a particular method that you use in the field or in a lab by carrying out a literature search is something that is about the application of knowledge and understanding. So as an R-Sci tech, it could be that you're using a method for the first time and your supervisor has actually asked you just to actually look up papers and literature online relating to what that method is about, the principles underpinning it. That's a literature search. As an R-Sci or C-Sci, which is more about solving problems and resolving situations, it could be that you've come across a roadblock in the method and you want to go back and look at how others, via papers or via technical forums such as ResearchGate, for example, which is a common one in science, how they've actually overcome those particular roadblocks in terms of data refraction of data generation and then implemented those in terms of their science. Of course, science is about working up the methods for the experiment, be that optimizing in terms of carrying out fixes at the bench or prior literature searches to understand the technique itself as an R-Sci tech or problems thereof as an R-Sci or C-Sci. Ultimately, it's about data that you generate in an office or in the lab. And of course, it could be that you can apply optimization skills to data output. Maybe you expedite data output, automate it. Perhaps you can introduce, say, as an RSci or a CSci, R to actually script your data output analysis. It could be that in terms of data analysis, that you're using different types, or you're introducing different types of statistical or analytical packages, such as GraphPad. And that's an example of application of knowledge and understanding invariably at those higher registers, RSci and CSci, which are more about not just understanding a standard operating procedure, but improvising on an operating procedure and actually coming up with de novo fixes or method replacements in the case of CSci. The next competency is about how you plan and organize. So say for an RSci tech, maybe it's just one example of that would be prioritizing your experimental deadline to meet your supervisor's needs. Okay, that said, and this is another point, when you fill out your competency form, don't just talk about what goes on in the lab, be that your experiments as an RSci or an RSci tech or data analysis on a computer. Talk about other things as well, such as interacting with finance. Okay, perhaps you do that as an RSci or as a CSci. Okay, perhaps you don't just stock take an order, you budget. Okay, so it's about thinking of your job in the whole. So an RSci or a CSci tech, an RSci tech or CSci by way of example, perhaps they're not just planning their own experiments per se. Perhaps they're organizing the lab and maintaining the equipment that we've given a pictorial example of in A for other people in the lab. Okay, it's about making sure the lab runs on behalf of others, and it's how you juggle those conflicting responsibilities. Teaching labs, if you're a teaching technician, is a lot about sort of working up methods, trialing methods, but also working in teams and actually making sure that the labs are set up on time. So that's part of your planning and organization. There's a section in B that I can't go into. It's a sub-competency, actually B2. And B2 is specifically about standards. It's often used by people to talk about things like waste disposal and in particular COSH, okay, lab safety. So for example, as an RSci tech, maybe you want to talk about the fact that when you're trained, you're not just trained in a particular standard operating procedure, you're trained to actually carry out that procedure in the context of good laboratory practice in a health and safety 21st century compliant manner. So it's about understanding the COSH forms, okay, as well as understanding the science at the bench. So you can talk about that as an RSci tech in B2. As an RSci, maybe as part of the training that I mentioned that distinguishes an RSci tech from an RSci, not only are you actually imparting knowledge, technical knowledge that's talked about in A of the standard operating procedure, but you're talking about that associated health and safety, be that COSH associated with how to carry out a procedure safely in terms of PPE, use of fume hoods, etc. But also disposal of, let's say, certain chemicals according to designated waste disposal policies. And you train, you inculcate the person you're training in that aspect of the procedure as much, if not more, than the actual technical standard operating procedure itself. Planning and organization is very, very open. So it can be things like, I came across one form that I assessed where they talked about the fact that their supervisor was going on family leave. And so they basically had to make sure that they planned everything that their supervisor needed to know. They'd learned what they needed to know in terms of what I've just talked about, or they had the right contacts to go to that person in the supervisor's absence in order to work autonomously or work in conjunction with pre-approved personnel in the absence of that PI. And similarly, COSH and lockdown. led to a lot of people being away from the lab, but a lot of people actually working very differently if they're key personnel. So you can talk about how things changed, okay, as part and parcel of planning an organization during lockdown, during COVID. Interpersonal skills and communication, that's really what it says on the tin. So if you are a CSI who is a team leader, it's about talking to your teams, okay, getting progress reports. Maybe, as I say, looking at your job laterally, it isn't just about what you do in the lab. It's about what you do outside. So many technicians at, say, RSI Tech or RSI level, they aren't just carrying out their own work, as I mentioned, they're organising the lab. And as part and parcel of that, they're probably stock taking and ordering. And that actually involves talking to medical reps. It means talking to company reps as part and parcel of, say, stock supply problems. So you could talk about that as identifying a problem or a situation if there is a stock supply problem. For an RSI or a CSI, it may be that apart from actually stock taking and ordering, it could be that you have a small consumables budget. This applied to me a few years ago, and I have to demonstrate to finance that actually I was balancing the books. And this brings me on to two final points, which is as part and parcel of interpersonal skills and communication, you can talk about modalities of communication, okay? So, for example, as an RSI Tech, perhaps, or as certainly an RSI and definitely a CSI, it may be that you're presenting posters at conferences or talking orally. Maybe if you're presenting posters, you're using Adobe Acrobat or PowerPoint, okay? That is a mode of communication, and you can bring that into your answer. On a more week-to-week level, it could be that you have lab meetings or group progress meetings where you're presenting in PowerPoint to your peers. And the other thing I want to mention is the fact that it's about, especially for an RSI and a CSI, and this is clear within the sub-competencies, it's about talking to different groups. So in the case of specialist communication, this is about training. This is about talking to people in your own lab, your own group, who share your background knowledge and your training in a particular way. Somebody that is doing effectively what you do and understands your own background, nomenclature and knowledge, etc. Okay. Whereas for RSI and CSI, it's about talking to non-specialists. So non-specialists might well be scientists or engineers, but they don't share your specialist knowledge. And a good example of that, for example, would be an RSI Tech, an RSI, or indeed a CSI, talking to an engineer if a piece of equipment that we've shown in A breaks down, and they often do. Okay, how do you get it up and running again? You will be talking in a different language to if you're training someone in a specialist technique. Okay, similarly, medical reps, and we'll come on to this in professional practice, maybe they're trying to sell you different types of purification kits or plasticware, okay? And they are often people with a background in science, but they're not there to talk specifically in detailed terms about a standard operating procedure pertaining to, say, PCR, but they might be there to sell you consumables in relation to that. So it's having those conversations which are distinct from, say, training your own say junior people like PhD students as an RSI, or indeed junior technicians. The other one I should mention is if you are a team leader as a CSI, and you don't have to be a team leader, and this is something that was brought up in the last talk, and if I get time I'll revisit this, it may be that there are structural things within the lab and you're talking to estates and services to actually improve the lab, etc., or maybe change labs. That's a different type of conversation parlance to how you train someone in a particular technical technique. So talk about those different scenarios within C. Professional practice you can almost think of as being a revisiting of A. So if, for example, you find a fix, an improvisation on a standard operating procedure in, let's say, A, but in fact, that is really basically a band-aid, and you want to actually fundamentally overhaul the method. It could be that you go back to scratch and you try and set up a new method. All right, it could be that you're doing that. The other example of that would be, let's say, if you're working in a biology sort of setting, maybe you're carrying out pilot experiments to actually work up the method that you will talk about finally in A. So it's about improving methods, either at the outset by carrying out pilot experiments in the field or the lab, or as basically a follow-on to a temporary fix that you talk about that in A as part of troubleshooting a standard method. The other thing that professional practice includes is a section on environmental sort of fluency and green lab initiatives. And it could be that you are responsible, let's say as an RSI or CSI in particular, for greening the way that your lab disposes of its plastics. And a good example of that, if you work in a lab, is making sure that you select suppliers that recycle the plasticware, and in particular the tips. So there is a section about lab sustainability and green initiatives. The main thing, however, in professional practice is about scoping and planning projects. So how do you plan a project prior to it starting, or certainly as a CSI in terms of budgets, time, personnel, and then actually get that method off the ground? And we'll come back to that later on in the second half. As an RSI tech, it could be something as simple as evaluating those plastic consumables that I mentioned before, in order to see if you can carry out the same operating procedure, but in a more cost-effective and maybe quicker way. Professionalism is those mandatory courses that we go on, such as equality, diversity and inclusion, but it can also include things like professional registration, coming to something like this and ultimately applying for professional registration. It can include things like data protection, which we all have to be mindful of, but it can be also technical standards as well, such as if you work with clinical samples, if you transition into a lab where you work with clinical samples, you're expected to do something called HTA training. So you're sort of mindful of using patient samples in an ethical way, anonymized, etc. And anything else indeed that you can think of that's a code of professional practice in your own environment. Okay. So this is about mixing and matching competencies. I mentioned the fact that you can use one scenario for different competencies, perhaps making a narrative thread between the sub-competencies thereof, or you can actually take one particular scenario and you can basically morph that or recontextualize that for the different aforementioned competency headings. So a simple example of application of knowledge and understanding would be carrying out an experiment independently as an RSI tech to generate consistent data, or troubleshooting, as I've already said, on that technique to basically yield data from refractory new samples as an RSI and CSI in particular. I've mentioned the fact that there is a section in B which is about standards. People talk about COSH, but it can be things like if you're in a biological sciences environment, it can be any standard. It doesn't specifically say COSH. It can be things like aseptic technique if you're responsible as, say, an RSI or a CSI for a tissue culture. C is interpersonal skills, so that is about training, as I've said. D is another example of where you can actually talk about new standards. So I've mentioned the fact that B2 in particular is about standards, and there's also a section for CSI, which is B4. There's only a B4 for, I think, CSI, which talks about lab sustainability and environmental ability and impact on your lab. So you can talk about, let's say, green initiatives in both the context of competency D as a professional standard if you're introducing it newly, or also in B. And this is what I've tried to do here. Perhaps you're using or you're transitioning to smarter purchasing. That's a standard. So that's B. But if you're purchasing, if you're stock taking and ordering on behalf of the other lab, and you're doing that via Science Warehouse e-purchasing, you're going to be communicating with other users in the lab. So that's an example of C. And similarly for stock taping lab consumables prior to ordering, that's also B and C. So you can basically permute these examples in any way that can be made to fit the competency mission objectives and the sub-competency objectives thereof. And this is just to sort of make the point that I'd like you as an RSci Tech, RSci or CSci to think about the different aspects of your job. So maybe you carry out an individual project where you are or not training others, following COSH, teaching others COSH, literature reviews for existing or new methods, equipment upkeep as an RSci Tech, improve performance by trialing different methods as an RSci, or completely new protocols as a CSci. But as I say, think about the fact that in your environment, particularly a lab, you may be stock taking and ordering. You may be maintaining equipment. It could be that you're maintaining that equipment and you have people on a lab rota, okay? Maintaining the equipment is lab housekeeping. That's something typically an RSci Tech would do. An RSci might be responsible for drawing up rotas for different people to look after different areas or pieces of equipment. That's lab management, okay? So think about the different aspects of your job, how you juggle those two seemingly conflicting things exemplifies planning and organization, competency B in particular. Finally, I just want to make one proviso here, which is people who are genuine team leaders and are therefore CSI, they may not be at the bench. And so competency A tends to scare them because they're not actually at the bench, but they are actually managing teams, okay? They are doing things within the lab, apart from looking at results, discussing them with teams. They might be responsible for writing reports to introduce new pieces of equipment contract tenders. They may be responsible for lab inductions related to health and safety, etc. They're all examples of the application of knowledge and understanding. And in terms of the lab itself, as I put here, new equipment, space allocation, updating of water purification systems, stock auditing. And if you are a CSI line manager, it could be that you are also involved in building infrastructure, okay? So that's an example in terms of planning with B, but also new initiatives, which would come under D. And as part and parcel of that, you will obviously talk to the users of the lab who will be affected by these physical changes to the lab. So that's talking shop to others, C. What I want to talk about in the last 10 minutes before we take a break and go into the more interactive stuff is I've given you examples of work practices that you can recapitulate yourself to fill out your own competency form. And let me make the proviso, or let me make the refrain, that if you need assistance with how you write your competency answers, or perhaps if a particular subject matches the competency statement in terms of how you've written it, feel free to drop me a line at that initial email and I will do my best to actually support you, okay? But having decided that your competency scenarios are right and optimal, and let me just say, this is not an assignment. Putting together the competency form and submitting it on CAP is not a timed assessment. If you want to spend 6 months, okay, thinking about what you've done and moreover what you'd like to do to make your competency form stronger, then do that. So be proactive as well as reactive. But having chosen those scenarios, whether you've put them together now or whether you have put them together over a series of months, and that is really at your discretion, how do you actually go about writing an answer that's conducive to passing? There's 2 independent assessors that look at it. How do you actually satisfy the assessors? How do you write what I refer to as a competent competency answer? Well, the first thing you need to do is your example clear and relevant? And by that, I mean, put yourself in non-specialist shoes. Your 2 assessors will be STEM for certain, okay? but they may not share your subject knowledge. They may not be specialists, okay? You might, for example, be an analytical chemist or an immunologist, and one of your assessors might be an archaeologist. So they're trained in science, but they may not understand the nuances, the minutiae of techniques you're using. So make sure your example is clear and detailed, but concise. Don't give an SOP, but if, for example, you're using a particular technique, give a sentence about what that technique is. If, for example, you're using, let's say, chromatography, just point out that this is a way of purifying an analyte, okay? And then, as it said in the video, a competency form is about you, so you need to make sure it's autobiographical. It's okay to introduce your answer about what you do in a team if there are overall team objectives, but what the competency form is about, what the assessor wants to apprehend clearly, concisely and unequivocally is that you carried out that particular technique. In other words, as it said in the video I showed you, make sure your answers are replete with I and not we as part of a team effort. It must be something you have personally undertaken. Okay. As I've said before, can you list your outputs? Choose examples where you identify a situation in the first paragraph. You talk about the method that you've selected and you give a comprehensive but not too detailed overview of what that method does and why you do it. And then talk about the outputs. Make sure that you can validate the method you used that you introduced in paragraph 1 in terms of things, perhaps metrics or just general statement like it worked, it made it better in a third paragraph. So what you do in essence, therefore, is outline the problem in the first paragraph or situation. In the second paragraph, you talk about what solutions you posed. There might be a series of methods you could use to address the problem or situation. Okay, talk about why you selected it and talk a little bit in order to satisfy non-specialist assessors, a little bit about the science. So, for example, if you're using something like HPLC, define HPLC as high performance liquid chromatography, okay? Don't just presuppose that the assessors will know acronyms for particular analytical techniques. And then, for example, include a sentence like this is used to purify my analyte of interesting. Finally, in that third paragraph, did it work? Provide outputs. So essentially what I'm talking about is write your answer, those 3 paragraphs, up to 1,000 words for a particular subcompetency in terms of the situation, the task, the action, the solution that you implemented, and the result, star. And I'll add one more thing. If your job is quite wide-ranging in terms of what you do, it is perfectly permissible to include 2 scenarios, okay? So it may be that you have more than 3 paragraphs. As long as you're below that 1,000 word limit, which you cannot physically in CAP go over, that is fine. I would say for our Tech, 1 scenario written, as I've said, is acceptable. If as an RSci and a CSci, by definition, you are doing more things, your job description is more wide-ranging, maybe include a couple of examples conforming to STAR to use up those 1,000 words. So as I've said here, don't talk in non-technical language. Provide definitions of acronyms. If a publication is cited to validate a statement, make sure you cite it exactly. And the other thing I'd say is make sure that you upload that publication in supplementary materials, perhaps number them so that you can number what they are in your answer. So there's a clear and unambiguous mapping of statements you make in your competency reports to support materials like publications. And finally, it's not a laundry list of multiple scenarios. You must demonstrate that what you've done has been effective by providing outputs. So situation, task, action, result. That is the name of the game. I think at this point we've covered an hour, so we're sort of on time. If we can maybe go off for now and perhaps come back at about 10 past 1. No, sorry, 10 past 3. What am I saying? 10 past 3.